Hello everyone, welcome to a new chapter. In this video we are going to talk about continental drift. But first, let's look at the evolution of the idea and how it came to being, and what was the old perception of the scientists on the continents of the surface of the earth and their positions. This is a map of the earth as we know it, and these are the continents. The continents seem to have a fixed position. So for example, this is Southern America. It is located in the southern left hemisphere. This is Africa. It is kind of located in the middle. This is the United States. It is located in the upper left corner. So these are the continents, and they seem to have a fixed position. And this was the belief for the longest period of time. So what I mean longest period of time, I mean since the beginning of when man tried to map the continents until the 1950s and 60s. Scientists believed that the continents had a fixed position and they were exactly at the same position relative to each other. However, this perception could not explain some phenomena. One of those phenomena were fossils that could be found on continents that were separated by large distances. So for example, this animal that is called Cynoognathus, it could be found in the middle of South America and then all the way to Africa. So identical fossils were found on continents that were separated by thousands of miles. And this was impossible. There had to be some kind of connection between South America and Africa for this fossil to be found across South America and Africa. And you might say, well, why is it impossible? We find a type of fossil here in Southern America, and then we find the same type of fossil in Africa. Well, let me put it in perspective for you. If you find remains of Africans, of Southern Americans in Southern America, and then in Africa, currently these two continents are apart by thousands of miles. But if you find remains of Southern Americans in Southern America and Africa, it would be puzzling. How could that happen? How could Southern Americans live in Southern America and in Africa, even though they did not have any way of transportation? They could not travel thousands of miles, or they could not swim thousands of miles for them to exist in Southern America and Africa at the same time. That's the problem. So when we find a type of fossil in Southern America and Africa, or when we find another type of fossil, so for example this one that is called Glossopotris, all over we could find it in Southern America, in Africa, in Antarctica, in India, and in Australia. This is very, very puzzling for scientists. The perception that the continents were apart and they had a fixed position could not explain fossils that were found all over the continents. Another phenomena that cannot be explained by the idea of continents having a fixed position was mountains of comparable age and structure are found in the British Isles, USA, Scandinavia, and in Africa. So in the northern west part of Africa and then the northern east of the United States, in Scandinavia and in British Isles, there are rocks, there are mountains actually of comparable age and structure. Somehow it feels like these rocks or these mountains, once a long time ago, they formed a continuous belt of mountains, but somehow they got separated. Somehow, like a piece of paper, when you tear it apart, somehow the continents were torn apart. Lastly, another more interesting phenomena that cannot be explained by the idea of the continents having a fixed position was there were evidence of huge ice sheets that 300 million years ago covered extensive parts of Africa, India, and Southern America. Somehow and for some reason, the southern part of Africa, the southern part of Southern America, and in India were covered in big ice sheets. This was very, very puzzling for scientists because these areas are kind of close to the equator and they're supposed to be hot. How could 300 million years ago these areas were covered in ice, and if you just walk probably 100 or 200 miles, you'll find swamps, evidence of hot climates? How could this happen? How could these two opposite climates exist beside each other? So evidence of paleoclimate, evidence of fossils living across the continents, evidence of rock types that starts in one continent and ends on the other. All these evidence pushed a guy that is called Wegener, or Alfred Wegener, to an idea that is called continental drift. And this idea was extremely revolutionary for geologists and the way they look at Earth, or generally the way that they look at continents. And basically the idea of continental drift says that continents move, or continents gradually drift on the surface of the Earth. So as you can see it in this animation, at some point of time, all continents were one big land, or one big land mass. But somehow, as you can see right here, somehow they got separated. One of them went this way, the other continent, for example Africa, went that way. At one point of time, the entire, or all the 7 continents that we have, they were all one big landmass. But somehow, due to mechanisms, these land masses got separated. And Alfred Wegener, for his idea of continental drift, he brought the evidence that I showed you, or the phenomena that I showed you that cannot be explained by the idea of the continents having a fixed position. He brought fossil evidence, or identical fossils that were found on continents that were separated by thousands of miles. He suggested that if these continents were once together, it could explain how these fossils could exist across continents. Also, rock types, mountains of comparable age and structure, are found in the British Isles, USA, Scandinavia, and Africa. Wegener brought this evidence to support his idea or his hypothesis of the continents drifting, or the hypothesis of the continental drift. He said that if the continents were once together, it could explain how mountains of comparable age and structure could be found in continents that are now apart by thousands of miles. Lastly, evidence of paleoclimate. Since Wegener was a student of world climate, he suggested that all the continents were once together, and specifically they were all linked to the South Pole. That's why we had big ice sheets, or evidence of big ice sheets, in Africa, in South America, and in India. Since the landmass were all together, that could explain why we can find evidence of extreme cold in areas that should have evidence of extreme heat. And all this were evidence that were given by Alfred Wegener of the idea of continental drift, or the gradual drifting of the continents on the surface of the earth. So just like that, as you can see in the picture, once all the continents were one big landmass, and slowly they were separated and they become the continents that we see right now. One big landmass that is called Pangea, it turned to South America, Africa, Asia, Antarctica, Australia, and North America. And as you can see in the picture, slowly these land masses get away from each other. This seems like a plausible idea, but it got rejected very, very bad. The scientific community did not agree with Wegener. He proposed his idea of continental drift in 1915, but it wasn't until the 1950s and 60s where the scientific community gradually started to accept his idea, even though he died in the 1930s. So after 20 or 30 years of his death, then the scientific community gradually accepted the idea of continental drift. And the reason for this was the idea of continental drift missed a crucial ingredient, and that was the driving force. Okay, so if the continents were actually getting away from each other, or if the continents are drifting, what is driving this drifting? What is driving the continents to get away from each other? Since Wegener could not explain this, the scientific community did not accept his idea, or it took them 50 years to accept it. Another reason for the rejection was Alfred Wegener proposed the rating of the motion of the continents to be 250 centimeters per year, and that was very, very high. The scientific community could not accept this. They could not accept that a continent, a big continent like North America or Asia, is drifting 250 centimeters per year. If it was drifting 250 centimeters per year, it should have been noticeable by someone. So for these two reasons, the idea of continental drift was not accepted for 50 years. But in the 1960s and 50s, with advances in technology, the scientific community accepted the fact that the continents are actually getting away from each other in some parts, and in some parts they are getting close to each other. So the hypothesis of continental drift became true. And it's not that long ago, it's only 50 years ago that the perception of the continents not having a fixed position became true. In later lectures, we'll look at how advancement in technology led the scientific community to accept the hypothesis of continental drift, and what kind of mechanisms drive continental drift. And with this, we come to the end of our lecture. To recap,